So we discuss about the basic metric calculations, that is the classic metric calculations. And also we see how the metric is going to manipulate it and how my successor, feasible successor is going to be changed. And even we understand how to figure out who is going to be successor, who is going to be feasible successor, what is the feasible condition we have, what is the RD, what is the FD, and what is the AD, and what is the feasible conditions. So I hope this is clear to everyone, right? In fact, Sabir and Jason, I hope there is no doubt and you are very much aligned with the, whatever we discuss.
Yes, sir.
Yes. Now, there is a term in EIGRP that is known as the wide metric. So we configure IPv4 and IPv6. So first of all, if I want to use the wide matrix, right? Let me put it here, IPv4 and IPv6. If you are going to use any EIGRP in normal classic mode, okay, they only use the classic metric. Okay, IPv4 use by default that classic mode, not named mode. Okay, then it is going to use the classic metric. And in the classic metric, we have the K1, we have the K2, K3, K4, and K5 value, which help to calculate the composite metric, right? Composite metric. But if I want to configure this EIGRP in named mode, okay, in that situation, even I can use the wide metric. And what is the wide metric? This wide metric can use K1, K2, K3, K4, K5, and K6 values. This is going to be used for the wide metric. Clear? Now, if I talk about even if I want to use the IPv6, this is not going to support your classic metric. This is going to support your wide metric and not going to support in classic mode. It is going to support in the named mode only, even IPv6. So classic mode is just designed for the IPv4. Okay, I can use the classic metric, but if I want to use the wide metric, I need to change for EIGRP configuration from the classic mode to named mode, and then I can use the wide metric. Now we have to understand what is difference between wide metric versus classic metric. This is going to be asked the questions, right? Classic metric versus wide metric. So what happened when you go for the EIGRP? EIGRP do the, bandwidth calculation, means it is going to do the metric calculation based on the link bandwidth. Okay, let me show you. We discussed yesterday, right? If I talk about EIGRP metric calculation, so default like EIGRP interface metric table. So if I go here and I'll open this wide metric and let me see. Let me open some articles. Okay, so okay, see, so you can see this bandwidth. Okay, if I have 10 Mbps, this can be this bandwidth. Delay this one and bandwidth this one, and delay is going to be there, right? And if I have 1 GPS, delay is going to be there. This is my 100 Mbps, this is going to be delay. So this delay in value and delay in second. So this is the microseconds. You can see use second. Even my link is getting 10 Gbps and 1 Gbps. Both have the same delay. You can see. So the delay is going to be same. It's not going to be change. Means whatever the link speed we have, that's maximum delay can be happen in my basically classic metric calculation, that is a tens microsecond. So if we have the topology R1, R2 and R3, and this is going to be R4 and R5. So R3. This link is suppose 10 Gbps, 10 Gbps. And this link is suppose 1000 Gbps and 1000 Gbps. If you check this route metric in the classic, what is going to be happen? What do you think, guys? Both is going to be equal.
Yes.
Why equal? Because both have the same delay precisions. That is the delay precision here is going to be just 10 microseconds. So even it is going to understand both route have the same metric, which is not good. Even my interface is going to be higher, that is not going to represent their delay, because this link delay is going to be quite lower if I compare this link, because the more higher than this one. You can think about if I have this one pipe, right? This pipe sending the water here, and I have another pipe here. Which one is going to send more water? A or B? B, right? Because it's a wider pipe for me. So if this pipe is better, then it's going to be take lesser time to just transmit the more water. But for EIGRP, it is going to be same. So to address this problem, means limitation of the classic metric, bandwidth measurement, they have the delay precision, that's the fix. After 1 GPS link, it's going to be 10. Even more than 10 GPS link, we have to be always consider that that's the same delay precisions. But if I want to measure this delay and I want to calculate actual bandwidth based on the my wide metric, so then they use the another metric that is known as the wide metric. Wide metric use the delay precisions not in the microsecond. They use in a picoseconds, which is quite higher than microseconds. Means quite lower than picoseconds is the like higher, means lesser than the microseconds. It's going to be take calculations, microsecond, picoseconds. So it's going to measure the delay in the picoseconds rather than the microsecond, which is going to be greater precisions. Means it is going to give the greater accuracy of the link calculations. And that's why they are going to use the K6 value, which is going to measure what is my loss in link, means even minor loss, jitter, energy fluctuations, anything. So that's why they use the new calculations in this wider metric. They use the K1 into bandwidth, that is a default formula, and that K2 into bandwidth, then it is going to be whole 0, and then 256 minus load, whatever the means. Let me show you, might be it is written somewhere, this formula. No, this formula. So this is going to be a default formula, but they're going to add one more value here. That is going to be your K6. And that K6 is going to be more calculate, right? That is going to be K6, and it is going to be extended precisions, extended, which is going to be calculate jitter and all. So probably I'll show you the table. You're going to find somewhere. Let me show wide metric. Yeah, probably this one is going to be there. So this is my default like K value, but you can see K6 is also going to be 0, but they must be talking somewhere. This is the, you can read it, this one. The enhanced interior gateway protocol routing composite mattering cost based on the calculating the bandwidth, delay, reliability, load, and the K value. It's not a scale correctly. The high bandwidth interface or Ethernet channel resulting the incorrect or inconsistent routing behavior. You can see here, the lowest delay that can be configured for the interface is 10 microseconds. That's only have the problem with the classic metric. As a result, high speed interface such as 10 Gbps and even more than higher than 10 Gbps, that will appear EIGRP is a single G interface with the same bandwidth. This may cause the undesirable result equal cost load balancing. That is going to be happen in our case also. If both have same metric, then it is going to do the equal cost load balancing. To solve this problem, EIGRP Wide Metric supports 64-bit metric calculation and routing information based scaling that provide the ability to support interface either directly via the channeling the technique or port channel either the maximum this terabyte. You can just configure. So they use the K6 value also, and this K6 value you are going to find extended attribute that is going to calculate your loss and jitter as well, or any kind of the fluctuations. So you are going to get some kind of the calculations here and all, but let me show you how it is going to happen. So, but I hope you guys understand at least, right? Wide metric. What is the use of the wide metric? So if I just tabular point of view, if I just calculate, might be if I just explain some parameter. So there is if you I'm going to use the classic metric. Classic metric. This is going to be 32 bits. Okay. And wide metric, this is going to be 64 bit. That's use the value for the metric size. Means metric size means this is the size of metric. Size of metric. So if you go 2 to the power 32, whatever result is going to be 4.32 billions address. And if you go to the power 64, it's going to very higher value. So this is the one thing. Means the size of metric. I'll show you how the size of metric is going to be happen. So this is the size of metric. Let me show you. This metric they are talking about. Let me show you. So show IP route. This is your metric. So this can be larger to the 32. It means this value can be up to this range. So power 32. This one. This metric can go up to this level, this value. Okay. This is the size of metric. Means this value maximum can go up to this range. But if it is going to be wide metric, this value can go even calculator not able to understand. Okay. So this is a difference between the size of metric. It's clear, Jason, Sabir?
So this point I didn't get it. So 32 bits are basically for what?
Size of
For
metric means the number, the value which is going to be there. This value, this metric
if okay, if you
is this
mean all the K values are on, then this size can go up to the maximum.
that much value. That means 43 billions it can go, not more than that. This is
Okay.
size, this value.
If every K value is on, you mean in that case it will be
No,
bigger.
it is going to calculate based on your link value. Means if I have the, see, if I have the serial link, you can see this is the metric.
Yes.
So this value can go there, right? If this is a serial link, and
Okay.
means this value can go here. If I just limit the value, like you cannot go more than 40,000. So I cannot put this value here, right? Metric. So this serial
Yep.
metric calculation not be happen, right?
Yep.
Similarly, that's why they given this value. 32 bit, it can go up to this number. Means this value of
Okay.
the calculation metric, this value can go up to this range in case of the your classic. Now you got it?
Okay. I got it.
Basically, this metric is going to happen. But if I'm going to use this wide metric, then this value can go even more bigger than that. I'll show you how this value is going to be changed. Just note this number, okay? If I
Okay.
configure metric, you're going to see this value is going to be changed. Now it's clear?
Yep. Thank you.
Sabir, you clear? Okay.
Yes, Philip.
Okay. So now the second value, this classic metric only support the IPv4. This is going to be support IPv6 plus IPv4 both. This is going to happen. This is going to calculate the metric based on the K1, K2, K3, K4, and K5. But this is going to add K1, K2, K3, K4, K5 plus K6. This is going to be added here. And this going to be same metric for 10 Gbps, 1 Gbps, and even more than 40 Gbps. But if this is going to be used, it is going to be used different. This is going to use microseconds. This is going to be use the picoseconds for the metric calculation. This is the difference between the classic mode and the pure wide metric. Now let me do the configuration of my wide metric. Means I will just do calculation for the which mode? Wide mode. Sorry, named mode EIGRP, and you will see that how it is going to be enable the wide metric. K6 value I'll show you. So let me show you. I will show you then the calculation how it is going to be done. Hold on. I can. Okay. So show run section EIGRP. First, I'll remove the EIGRP configuration. Okay, it's not running EIGRP. Show run section EIGRP. Okay, show IP EIGRP neighbor. So we are not running any EIGRP. Show IP interface brief. Yes, we have the interface configured. Okay, let me quickly ping and test everything is working or not. .2 is working. It's fine. Show IP route. Show run. Okay, so let me configure the EIGRP. That is going to be named mode configuration. Okay, let me first stop the recording.